Now the specifications for an endodontic instruments. Instrument shall be numbered from 10 to 100. Shall be numbered from 10 to 100. So the number would advance by 5 unit from 10 to 60, and the number would advance by 10 unit from 60 to 140. So that it could be like 10K file, 10H file. So the number denotes the 1/100th millimeter of the tip diameter. That is, when we are talking about 10K file, that is the tip diameter of the instrument would be 10/100 millimeters. That would be 0.10 millimeter. The tip diameter of the instrument will be D0 or D0, and it would be 0.10 when we are talking about 10K file, and when we are talking about 20K file, it would be like 0.20 millimeter. That is the D0 or tip diameter of the instruments. And with the every increase in length of the instrument, the diameter of the instrument would also increase. So with 1 millimeter increase in file length, diameter would increase by 0.02 millimeter. So the diameter at D16 would be different from diameter at D0 or D0, and the cutting edge of the instrument would be up to D16, and the length of the instrument could be like 15 millimeter or 21 millimeter. So this is the instrument of size 25 millimeter, and the instrument could be also of 21 millimeter, and the cutting edge would be up to D16 only. That is the 16 millimeter of the instrument length. Now the diameter at D16 would be calculated as 0.10 plus 16 into 0.02 millimeter, that is likewise the diameter at D16 of 10K file and the D16 of 20K or 20H file would be like 0.10 plus 16, this would be like 16 into 0.02 millimeters, that would be like around 0.52 millimeters. Now when we are talking about the angle of the instrument, the angle of the instrument would be like 75 plus minus 15 degree at D0. It is the tip diameter of the instrument would be 75 plus minus 15. And now with the increase in taper, like the diameter of the instrument would increases, so its taper would also increase with each millimeter of increase in length of the instrument. When we are talking about 2% taper, the diameter would increase by 0.02 millimeter per mm increase in length of the instrument. Length of the instrument. And with 4% taper, would be like 0.04 millimeter. So the 10K file. Now when we are talking about the 4% taper, the tip diameter, that is D naught of 10K file. We are talking about the 10K file. 4% taper of 10K file only. So the D naught would be 0.10 millimeter, and with every increase in length of the instrument, the diameter would increase by 0.04 millimeter. Like I said, in 2% taper, with every increase in millimeter of the length of the instrument, the diameter would increase by 0.02 millimeter. So the D16 of 2% taper would be like 0. of 10K file is 0.10 plus 16 into 0.02 mm, and D16 of 4% taper would be of 10K file would be 0.10 plus 16 into 0.04. So the instrument thickness at D16 would be large of 4% taper. Likewise, when we talk about 6% taper, D16 would be more than the 4% taper. Now, some terminologies of the specification for an endodontic instrument. Taper denotes the per millimeter increase in the file diameter from the tip towards the file handle. Earlier, I have said that the per millimeter increase in file diameter from the tip towards the handle. Taper could be like 2% taper, 4% taper, or 6% taper of 10K file, be like 0.20 millimeter, 0.40 millimeter, or 0.60 millimeter. The taper should increase by 0.20 millimeter per mm increase in length. The diameter would increase by 0.20 millimeter per millimeter increase in length, and in 4% taper, the diameter would increase by 0.40 millimeter per increase in length of the instrument. In 6% taper, the diameter of the now about 6% taper, the diameter would increase by 0.60 millimeter per millimeter increase in length. Now, for example, when we talk about 10K file of 2% taper, 4% taper, or 6% taper, the tip diameter of the 10K file would be 0.10 millimeter only, that is the D naught, and the D16 of 2% taper, 4% taper and 6% taper would be different. Same and the different. D16 of the 2% taper would be different from the 4% taper, and the D16 of the 4% taper would be different from the 6% taper. So, the diameter would increase with the increase in tapering of the instrument. The tip diameter of the same instrument with either 2%, 4% or 6% would be same, and the diameter at D16 would be different for 2%, 4% and 6% taper. Now, the flute. It is the groove or relief on the working surface of the file which collects the debris as the file cuts through the substrate. It is the groove. It is not the working area, it is the debris collecting area. So, we are seeing it over here, it is flute. It helps in collecting the debris. And now the blade is the working or cutting edge of the instrument. So, this is the blade or cutting edge of the instrument. Now, the pitch. It is the distance from one cutting edge to the next, that is cutting edge to cutting edge distance is the pitch. It is not the distance of collecting edge, it is the distance from cutting edge to cutting edge. Now, the helix angle, it is the angle the cutting edge forms with the long axis of the file. So, this is the long axis of the file and this is the cutting edge. So, the angle formed by cutting edge to the long axis is known. Now, the rake angle. On perpendicular sectioning of a file, the angle which the leading edge forms with the radius of the file is known as the rake angle. On perpendicular sectioning, this is the perpendicular section of the instrument, the angle which the leading edge, and this is the leading edge. So, the angle formed by leading edge with the perpendicular section of the file is known as rake angle. Helix angle was the angle which the cutting edge forms with the perpendicular sectioning. Here the rake angle is the angle between the leading edge of the instrument to the long axis of the instrument. The rake angle could be positive or negative. Like on perpendicular sectioning of a file, the angle which the leading edge forms with the radius of the file. So, the radius of the file could be like this. So, this is the file, the file could be like semicircular or circular, and this is the radius of the circle, and this is the perpendicular sectioning of the instrument. So, the angle which the radius of the cross section of the instrument forms with the long axis of the instrument is basically the rake angle. So, it could be like positive or negative. When the rake angle is obtuse angle, then it is known as positive, obtuse angle. When it is acute angle, that is less than 90 degree, acute angle, then the rake angle is negative, negative rake angle. Radius of the cross section of the file with the perpendicular sectioning of the instrument. Rake angle is the angle between the radius of the instrument with the long axis of the instrument. So, when the angle is greater than 90 degree, it is positive rake angle, and when the angle is less than the 90 degree or acute angle, then the rake angle is considered as negative. Now, the color coding of the instrument. We can remember the color coding as PGP, that is pink, grey, purple. Pink is 6K and the grey is 8K and the purple is 10K, and the further white, yellow, red, blue, green, black, and further ranges from white to black, that is 15K, 20K, 25K, 30K, 35K and 40K, and from 45K further it will range as white, yellow, red, blue, green, black.